Hi everyone, this is Ben, and today I want to talk about the famous mathematician David Hilbert. David was a German mathematician who was known as the most influential mathematician of the 19th and 20th century. And he became interested in infinity and different things to do with infinity. And one of the problems that he came up with to get people to think more about infinity was known as the Hilbert Hotel problem. And basically what it is it's a hotel that has rooms 1, 2, 3, 4, 5, 6, and so on with no ending. So there's an infinite number of hotel rooms. And each of the hotel rooms is occupied. So there's a person in every room. So imagine there being a person in every room all the way down the line. So each of the hotel rooms is occupied. And the problem is that a guest comes in and wants a room. And the hotel manager kind of stops and he thinks and says, well, we don't have any rooms open. But then he stops and thinks, I think I figured out a way to get this new person in the hotel. And all he does is he does a very simple thing. He takes a person in room 1, moves them over to room 2, takes a person in room 2, moves them over to room 3, takes a person in room 3, moves them into room 4. And then, of course, room 1 is open for the new person, and the new guest comes in there. And that's how he accommodated the first person. Well, the second day, it gets even more complicated. A busload of people come in. And the problem is that the busload of people has an infinite number of people in the bus. So it's like a bus with an infinite number of people. And the hotel manager actually thinks of a way to get the infinite bus into the hotel. And what he does is he takes the person in room 1, moves them to room 2, takes the person in room 2, moves them to room 4, takes the person in room 3, moves them to room 6, and so on. So in other words, everybody's in an even-numbered room. So that means all the odd-numbered rooms are open, and room 1's open, room 3's open, 5's open, 7's open, and so on. And each person on this infinite bus gets one of the odd-numbered rooms, and they just keep going from 1, 3, 5, 7, 9, 11, and so on. So that's a way to get an infinite number of people into the hotel. Well, the third night it gets even crazier. The third night there's an infinite number of buses that come rolling in. So there's an infinite number of buses that come rolling in, and each bus has an infinite number of people in it. So you got an infinite number of buses and an infinite number of people in each bus. And the hotel manager does figure out a way to get these people into the hotel. And the way that he does it is pretty interesting, to say the least. He puts, again, the person in room 1 into room 2, person in room 2 into room 4, person in room 3 into room 6, person in room 4 into room 8, and so on, so that all the odd-numbered rooms are open. So now you have all the odd-numbered rooms open. And he takes the first bus, so we'll call this bus 1, which again has an infinite number of people in it. We'll call it bus 1. And he assigns the first person in bus 1 3 to the power of 1, which is room 3. Assigns the second person 3 to the power of 2, which is room 9. Assigns the third person 3 to the power of 3, which is room 27. And each person on that bus gets assigned 3 to whatever number they are. So they get all the powers of 3. That bus gets all the powers of 3. Then he takes the second bus, which again has an infinite number of people in it, and he assigns them the powers of 5. So 5 to the first for the first person, 5 to the second for the next person, 5 to the third for the third person, and so on. So the second bus gets all the powers of 5. Now the third bus is going to get all the powers of 7. The fourth bus gets all the powers of 11. And you just go to the next prime number. And the cool thing with that way is that there's actually open rooms then, because not all of the odd numbers get hit in this. So there's actually more rooms for additional guests. So there you go. So what did this Hilbert Hotel problem prove? It really just proves that infinity is just infinity. So in other words, if you add 1 to infinity, you still have infinity. You double infinity, you still have infinity. You multiply infinity times infinity, you still have infinity. So infinity is really just infinity, and that's what the Hilbert Hotel problem proved.